behavioral analysis allows us to, work out how they're looking to see that, and then, commercial software doesn't do that. So another good indication that it might be malicious. So some pros and cons of proactive controls. They're not, they're not the silver bullet for malware. So code analysis advantages, targets the vulnerability and just not the sample. So the actual list gets dramatically smaller. When you're starting to actually go over just the vulnerabilities and not having to worry about all the malware variants and all the pieces of malware samples, your database gets significantly smaller. You're actually analyzing the deobfuscated code and not the obfuscated code, so that also makes it a lot simpler. Polymorphic viruses basically just, kind of recode themselves, rebuild themselves, and just change the obfuscation code, which is how they get around the signatures. So being able to deobfuscate the code and actually, concentrate on the deobfuscated code is a lot easier. And the other big advantage is it's the real-time scanning on the actual content your users are accessing as they're accessing it. Real-time code analysis is actually pretty quick. It would add 10 to 15 milliseconds maybe of latency to a browser session. And don't believe any marketing material. If we're inline and we're scanning, we're adding latency. But it's very fast, so the users don't really notice that. But we're able, as your users are accessing their web pages, we're scanning that content as it's coming in and out of the organization. So it's pretty important that we're doing it on the content that your users are accessing, not what some cloud service is doing in the background. So some disadvantages. Even though I just said that it's pretty quick, it certainly does add latency. So if you're accessing a page that's got a lot of active and dynamic content on the page, then you are adding all this stuff together and you will have a slightly slower experience. But really today on the internet, to stay safe, users do need to expect some degree of latency when they're using it. If you're running on a gateway, then you have to assume that the client browser, you have to assume the client browser environment. Because you're not connected to the client browser in any way, you have to make some assumptions about, what order stuff is being executed and what's actually being executed and how it's being executed in the client browser. You have to make some of those assumptions when you're running on the gateway. And also, it can have a degree of false positives. Of course, very minimal, clearly, but it's more prone to false positives than a more, signature-based technology like AV scanning, for example. And then behavioral analysis, which is the second result option we showed you there. It doesn't even scan the code at all. It actually just analyzes the result. So behavioral analysis, in theory, notice I used the word theory, is the closest possible you'll get to 100% malware detection. But it's horrendously slow. To do each one of those observations is going to be 18 to 30 seconds, probably. Imagine waiting for each active piece of content on a web page, 30 seconds to load before you could view the page. Your user rejection rate is going to be pretty high. And it can also run all the files, which is a good thing, but it requires a number of large resources to do so. That server console that we're looking at before, that's actually a 4-way server with like 16 gig of RAM and horrendous amounts of disk space, etc. You do need a lot of resources to run behavioral analysis. So the new proactive controls, which are great, and we're really glad we've got them, they're not perfect either. So where does application whitelisting fit in? So application whitelisting is completely different, but it's very relevant to this conversation. It really does break the mold of just looking for the bad stuff. Today, if you're looking at the list of bad malware samples, like semantics database with the growth that's had, this list is a massive, massive list. The list is far larger than the list of legitimate software. So application whitelisting actually concentrates on the list of white applications, not the list of black applications. So it's basically a big, long list of application hashes. And those hashes are going to be done in 2 ways. Either your application vendor, like Bit9 is a good example of application whitelisting, they'll actually go away and maintain their database of hashes. So they go away and contact all the application vendors, work out when they've got new updates, new applications to be released. They analyze those applications, make sure they're good and free of malware. Then they create the hash of it. Then they push the hashes down to their customers. And the customers, if the hash is in the actual database, then I can run that and execute that application. The other way you can do it is if you're in an organization, and this is a lower level of security, but in your organization, you might want to take your standard operating environment, like your standard desktop build if you have one, and then analyze those applications, and then keep track of any updates that needs to happen. Somehow test them for malware. I'm not quite sure how you're going to do that. But test them for malware, make sure they're safe, and then add them to your own local hash database. That's another way you can do application whitelisting. So it basically works by blocking the execution of non-approved applications on the actual desktop itself. We're interested in this technology because at the gateway where our technologies sit, then we could certainly look at blocking any applications that aren't on the approved list from being downloaded. So for example, you might have browser plugins or codec updates or whatever they might be. If they're not on the approved hash database, then we would block them being downloaded through your email or web gateways. So application whitelisting has a part to play as well. So with that, I'm going to hand it over to Vadim, and he's going to show us how to get around all these great technologies.
Reactive technologies and proactive technologies. So I guess there is no need to explain how URL filtering, for example, can be bypassed, right? You take the same malicious code, put it on a different domain, IP, whatever. That's all we are done. Okay. So let's look at more complicated technologies. Okay. Well, I took the real malicious code. This code is widely spread in the wild. Okay, this is exploit for iPierce vulnerability that was detected recently. And what you can see here is some shell code, if string, and several JavaScript comments that cause Internet Explorer crash. So. Well, let's check this code with several antiviruses. Okay, virus total, we know, right? It's, as you see, it's 31 from 41. Well, it's not perfect, but for JavaScript, it's not bad for antiviruses. Okay, 75%. So, now let's change the code a little bit. Okay, let's try it. Well, what I did here, this is actually from this code. You can see here above, it's a shellcode string. As you can see, the shellcode is just a string, right? So, well, string, you can manipulate the string. What I did here is really small change. I changed the percentage U characters to greater than less than, and then in runtime I replaced it back. Okay, just finally I need my exploit working. Okay. So, what's the result of it? There's the code after the change. 16. Okay, it was 31, currently 16. Okay, it's a small change. We cut off half of antiviruses. Let's continue. Well, another small change. I'm just going to change the variable names. Nothing more. Okay, it's instead of knobs variable, I'll call it variables. Okay, and second change I did, it's in JavaScript you can call to a method for in two types. So you can call it like this with a dot, right? Or you can call it like this with a bracket. Once you call it with a bracket, it's the method type is just a string. So once a string, you can manipulate it, string manipulation. So I separated it for 2, for example. Okay, let's see. Well, this is the same code after some manipulations we did, and the result is 2 from 41. Okay. So we really 5 minutes manipulations. We actually got the code undetected by the antiviruses. Okay. So well, the explanation is very simple. That it's very easy to change JavaScript code. It's even more easy than change the executables when you need the source compiling and packing several stuff. So JavaScript is much easier, so antivirus has nothing to do with it. And it's all these changes before I obfuscate the code, right? Before obfuscation. Okay, let's continue. Well, the second sample I took once again, it's from the wild sample that you can see here the type of simple code obfuscation. You can see the button here, okay, some deobfuscation procedure, and here in the cycle the document write column that actually launches the code after deobfuscation. Okay, let's check it without with type of proactive control. JSON Unpack, it's probably you know it's JavaScript Unpacker. It's free security research service that you actually can go to their site to upload the code. Just pass your URL, and it will deobfuscate the code, and it can say is it malicious or not. Okay, so in this case, it says malicious, and it's right, it is malicious, and it found here several vulnerabilities. You can see here. Okay, so what I'm going to do is to change the code a little bit. Well, pay attention that the only thing I changed here, I read the document write column with the do while cycle. Okay, do while is going. That's the condition of the while. It's 1 greater than 2. It means it's going to run once. Okay, the same code. Pay attention to this semicolon here. Okay. Well, let's look at JSON Unpack result in this case. Benign. Okay. Interesting. Why is that? Same code. Benign. Well, the reason for it is that different JavaScript engines behave different for the same column. Okay? Remember the same column I talked about? So let's look at the simple sample of this pretty similar code, just to run out, for different JavaScript engines. Okay? Internet Explorer doesn't care about the same column. It triggers alert for both cases. Okay? Firefox is different. One, there is no semicolon, it trigger alert. One, there is semicolon, it doesn't. Okay? That's exactly the point we bypassed the JSON Unpack. As far as I know, JSON Unpack uses the same SpiderMonkey library as Firefox. So what happened here? JSON Unpack just didn't write this document right in the previous sample, yeah, column. So it didn't unpack the code. Once it didn't unpack the code, it didn't see the deobfuscated code, so it didn't know that it's malicious. Okay, so that's exactly the flow. The flow in different JavaScript engines is exactly the point to bypass proactive controls. Okay, that's why I wanted to demonstrate today. And we're ready to summarize.
Thank you. Quick shot there from one of my favorite movies. To summarize what we're really talking about, to maximize your malware detection, you need to be relying on multiple technologies, multiple engines, multiple products, all these multiple methods running at multiple deployment types, points. So, you know, in the cloud, at the gateway, on the actual desktop itself, multiple points, layer them all together, and it's even better if you can correlate information between them. And that is in the process of actually happening at the moment, even between vendors. You've also got to get the right mixture of reactive and proactive controls. You know, reactive controls are great, they're very fast, but they only know about what they know about. The proactive controls are a lot better. Well, they're certainly an improvement because you're able to start detecting technologies or malicious code that they've actually never seen before. But they have their limitations as well, as you've seen through the demonstration that Vadim gave, as well as some of the pros and cons that we talked about as well. So that was basically, I'm sorry if you came here looking for the 100% silver bullet for malware. There isn't one, but we did fool you to come along to the session anyway with the title. You know, try and maximize the types of technologies you're working on. There's no one right answer. Don't believe vendors. We're all the same. I know because I am one. Good luck with trying to detect that in your environments. Do we have any questions? We explained everything really, really well.
I was going to ask a question, but then you answered it yourself.
Oh, I'm sorry about that. Okay, great. I quite often actually ask my own questions and don't have the answer to that question, which is also a pretty interesting thing to do. Any other questions? Vadim and I will be around.